This is a trig word problem as requested. The kite is 72 meters, has 72 meters of string, and is 41 degrees above the horizon. It's being flown by a boy who is 1.7 meters tall. How high is the kite directly above the ground? So to solve this problem, the first thing we need to do is draw a very clear picture of what this looks like. So if the boy is here, that kite is being flown by a string that has a length of 72 meters. Kite is up here. And if I was to draw a triangle underneath, the angle in here is the angle of elevation. That's the number of degrees that this line is above the horizon. That's 41. Now also, the boy that's flying the kite is 1.7 meters tall. So that means that the height from here to here is 1.7, and the height from here to here would also be 1.7. So when I find this length here on the triangle, I'm going to have to add 1.7 meters to that to get the total height of the kite above the ground. So to simplify things, I'm just going to draw out my triangle so I can focus on that. I've got an angle of 41 degrees in here. I've got a length of string that's 72. And if we're looking at the kite directly above the ground, we can assume that we have 90 degrees right here. And I'm looking for, we'll call that y. That's going to be the height that the kite is above this point, which is also 1.7 meters above the ground. So this is what I'm looking for here, that y value. Now, to solve this problem, the first thing I'm going to do is I'm going to circle that angle. Now I'm going to label the rest of the triangle with respect to that angle. This is the opposite, because this is the side length that's across from the angle that we know. And this is the hypotenuse. The hypotenuse can be recognized as the side length that is across from the 90 degrees. It's always the longest side on a right angle triangle. If we look at our acronym SOHCAHTOA, the whole point of this is to determine if we're using sine, cosine, or tan. Have a look at your triangle. You are looking for opposite, and you have the hypotenuse. The O and the H go with sine, so we're going to use the sine. The sine of our angle is equal to the opposite over the hypotenuse. And now, looking at the triangle in question, the angle is 41 degrees, the hypotenuse is 72 meters, and the opposite is our unknown side length y. So the sine of 40, was that 42 degrees? 41 degrees, sorry. The sine of 41 degrees is equal to our opposite, which is y, divided by our hypotenuse, which is 72 meters. See that? We have a hypotenuse of 72, we have an angle of 41, and the side length we're looking for is opposite, because it's across from that angle in question. Okay, what we need to do now is determine the sine of 41. You can use a trig table, or in this case I'm using my calculator. And the sine of 41 degrees is 0.656. So 0.656 is the sine of 41 degrees, and that's equal to y divided by 72. Now, if y is being divided by 72, the way I can isolate y, the way I can get it by itself, is to multiply both sides of this equation by 72. So if I multiply 72 on both sides, Over on the right, they cancel one another out, and I'm left with y by itself, and y by itself is equal to 72 times 0.656. And when I multiply 72 by 0.656, I get 47.24. Y is equal to 47.24. Now, does that make my answer 47.24? Let's look at the question again. So we have a boy that's 1.7 meters above the ground. He's flying a kite 41 degrees above the horizon with a string of length 72 meters. So with a length of 72 meters and an angle 41 degrees above the ground, we have an opposite side here, that y value, which is 47.24. But remember, that y value is only telling us how high the kite is above the height of the boy. To find the height above the ground, we must add the height that the top of the boy is above the ground, the 1.7. So if y is 47.24, the kite is 47.24 plus 1.7 meters above the ground. So that makes our final answer 47.24 plus 1.7, 48.94 meters above the ground. So to recap here, we were given a word problem where we were given a length of string of 72 meters at an angle 41 above the horizon. So I drew that into the diagram here. And it's being flown by a boy that's 1.7 meters tall. So we've got to express in the diagram that that triangle sits 1.7 meters above the ground. We're then looking for the height of the kite above the ground. So from drawing a triangle inside of here, we've identified that the side length opposite of that given angle is the side length that we're looking for, which will also express the height of the kite above the boy. And if we add the height of the kite above the boy to the height of the boy above the ground, we can properly answer this question. So once the triangle was set up, we realized that we're looking for the opposite, and we have the hypotenuse. And opposite over hypotenuse is the sine of the angle. So we write in the formula, the sine of the angle is opposite over hypotenuse. We calculate the value of the sine of the angle, and then we isolate y, which was the opposite. It was being divided by 72, so we've multiplied both sides by 72, getting y by itself, which gave us a value of 47.24. Once you're finished your analysis, though, you must reread the question to make sure that the number you came up with answers the question. So we take our 47.24 and we look here and realize that the 47.24 is not the height of the kite above the ground, but it's the height of the kite above the top of the boy. So we've got to add the height of the boy to it. Our final answer is what we get when we add those together, and it's 48.94.